Hello guys, now we will discuss very important control system concepts from the very famous book Control Systems Engineering by Norman S. Nice. So a control system is defined as a system where we have a certain input and we get a certain output against this input. So for a system we have two important types of response, that is the output. One of which is the transient response and the second is steady state response. Transient response is the short-term response, whereas the steady state response is the long-term response of the system. In this figure, we have an input command and we have a certain response of the system. And we have here transient response and here the steady state response, and then we get an error which is known as steady state error, which is the difference between our input and our steady state response. Secondly, there are two types of systems, open loop systems and closed loop systems. In open loop system, here we have a simple block diagram where we have an input which goes to the controller, and then a disturbance is added which goes to the process plant, which can be a control valve, and then we can add another disturbance in terms of noise and we get an output. There is no feedback element in this system. We give the input and get the output. So this type of system is known as open loop system. Whereas in closed loop system we have a feedback element. Like here we have an element which measures the output and gives its response to here at summing junction, where we get the error signal. So feedback system is a kind of regulating system where we can maintain a certain set point. We can see these definitions here. A generic open loop system is shown in figure. It starts with a subsystem called input transducer, which converts the form of the input to be used by the controller. The controller drives a processor plant. The input is sometimes called the reference, while the output can be called as the control variable. The distinguishing characteristics of an open loop system is that it cannot compensate for any disturbances that add to the controller's driving signal. For example, if the controller is an electronic amplifier and disturbance 1 is noise, then an additive amplifier noise at the first summing junction will also drive the process, correcting the output with the effect of the noise. So this open loop system cannot compensate itself, whereas this feature is added in the closed loop system, which can be compensated against the disturbances in the system. Other important, now we will discuss another important waveforms, the test waveforms, which are used in the control systems. First of them is the impulse, which is represented by delta t, and its description is delta t is equal to infinity for t is 0 minus to 0 plus, and elsewhere it is 0. So if we integrate from minus 0 to 0 plus, it's equal to 1, and it is used in transient response model. The second one is the step input, which is denoted by u of t, and its definition is it's 1 for t greater than 0 and 0 for t less than 0, and it's used for the steady state error calculations. The third one important is the ramp, which is denoted by t into u of t, and t into u of t is equal to t for t greater than equal to 0 and it is equal to 0 elsewhere. It's again used in the steady state error calculations. The other one is parabola, which is equal to half t square ut. Half t square ut is equal to half t square for t greater than equal to 0 and 0 elsewhere. The final one is sinusoidal, sine of omega t, and it is used in transient response model. Hello guys, now we will